Welcome, everybody. Tonight, we're going to continue our Module 7 lecture and demonstration. We are, picking up where we left off. We made it up through slide 46 last time. We have to make it up to slide 81. I don't think that we'll get that far tonight. I think that's a little ambitious, but we'll try to get most of the way there. The first topic for tonight is this special kind of concept or keyword that we use inside of C# called static. The first thing I'm going to say about it is that static is a keyword that you find often in object-oriented programming languages, especially what we call the C-style languages. And C# does derive from the original C programming language, but it is its own variant. Static has a particular meaning as a word, and if you think of what it means as a word, it's not like when you rub your feet on the carpet and touch something and you get a shock. Well, that's a static charge, right? That's a little bit different. But what static means otherwise as a word is that something isn't changed or unchangeable in a sense, right? It's maintaining its state. So that's kind of a good way to think about it. Now, the reason that we use this is to kind of enable some higher level functions with objects and classes and give us capabilities that make sense from a logical standpoint. So let's start first by talking about all the kind of bits and pieces that we've kind of been working with, and then how we're going to kind of add all that stuff into what we're doing so we can do an example of how this operates. First of all, we'll talk about objects and talk about what we call instance fields. So in other words, when you create an instance of an object, right, every one that you create, every time you create an instance of a class and make an object, each object gets its own copy of its instance field. So for example, I've been kind of generally calling them data fields, right? So in other words, the data or the variables that we put at the top of that class are what we're talking about. So when I make one rectangle, it'll have a length and a width, for example, of a certain size and shape. And then I create another rectangle that has different properties for those. Those are unique to that object, right? So every instance gets its own copy and it stays with the object, right? It doesn't make sense that all rectangles are the same size and shape. Not logical, right? So why are they different? That's kind of the point. So we can have the one that's got the length of 5, width of 10. The other one's got a length of 7 and width of 3. And they're two unique objects. I mean, heck, we can see them on the screen, right? And it helps us to conceptualize that whole thing. Now, objects also have methods, right? Methods are basically we'll think of them as built-in functions that perform certain actions, right? So an instance method allows us to do things with that particular instance of that class. So for example, if I have one rectangle and I've named it kitchen, and I trigger its getArea method, it's going to return a value, but the value that it's returning is relative to that particular instance and no others, right? The calculation is coming from the length and the width. You guys remember putting all that together. So when we're doing a getArea, the response from the object will be unique unto the object we're pulling it from, right? So if I, and you should recognize that, like if I look at let's say the area of this rectangle and the area of this rectangle, they are different because the values are different. But even if the numbers were identical, they're still separate objects and their methods are separate from each other. Now, when we start throwing in the concept of static, this is where it gets kind of bizarre. Normally, the data fields and the methods belong to the object itself. But static members do not. They belong to the class from which they were blueprinted from or created from, right? So all of the instances share that particular aspect of whatever that class is. So if I take a data field, or let's call it an instance field from the class, and I make it static, that is available to all the other classes, but it belongs to the class. It doesn't belong to the instance, and the class is what controls it, right? And what's kind of interesting about that is, if we're counting, how many rectangles we have. This is the example they're using. If we're counting and the count is 1, all of them can access that count, and they're accessing the same count. I don't think that's a particularly great example, but you'll see kind of the concept of it as we kind of roll forward here. And it says you don't need an instance of the class to access the static members. So I can also access the static members without having the object created. Even weirder, right? Because it travels with the class, it doesn't travel with the object. So if we apply this to the data fields, we call it static fields. So it says fields declared with the static keyword belong to the class. Okay, we've said that already. Only ever one copy in memory. Maybe that's not very good English there. My English teacher would yell at me for that one. There's only, there's only ever one copy in memory, regardless of the number of objects. And notice when we declare the data field, we put the keyword static inside of it to let the C# engine know that this belongs to the class. It doesn't belong to the instance. It says they're only initialized once, and that would be the first time you call upon it, it will be initialized. Right? Once it's initialized, all the other instances can access it as well. Now, there's also static methods, right? So not to confuse the two, but the static methods also can be used without an instance of the class, which is also kind of weird. And the example that we have here on the slide is it's often used for utilities like math. So for example, when we call upon our math libraries, the math libraries, really all they do, they don't really contain, data fields, but they do contain a lot of methods for doing math. So if you can imagine, we've written code in class, although I think for the most part it was for demos, right? Where, like, how do you figure out which number is smaller? If you're given like 2, 3, 4, 5 numbers, how do you know which one is smaller? Well, you read a bunch of if statements. You go, well, if this one's bigger than that one, and if this one's bigger than that one, eventually you water it down and you figure out which one's bigger, right? So a math library really has a bunch of methods inside of it that perform these actions, and we're calling them, but they belong to the class of math. And it's not, being instantiated. We're just calling upon the method and using it, right? It's a static method. It doesn't travel. I'm not creating an object here, right? And so we call the static methods using the class name, but, so the class name here is being math.min. So that's why we use that syntax. So when I'm calling something out of the math library that's a static method, I do have to call the class to bring it in. I can't just say min xy and it'll work. I have to, which class are you pulling this from? Oh, you're pulling this from the math class. It's static. Okay, go ahead and use it. That's kind of the mentality of it. All right, so a good way to kind of demonstrate this is let's build a class that does this. So we're going to make an employee class. We're going to have field names for name and salary, both passed into a constructor. We'll have a field for employee ID, not passed into the constructor. And we'll explain why in just a second. And then each employee that gets hired gets a successively higher ID. So in other words, first person we hire will be employee ID 1. The second employee we hire will be employee ID 2, right? And it makes you wonder a little bit about like your student IDs, for example. So like if you look at like your student IDs that you guys receive here from school, you can kind of tell like how long ago somebody took a class at the school because they keep the same student ID even if they studied here 20 years ago. they come back with the same student ID. And so this has happened to me because I like way back when I went to like MATC and took classes, and like my ID number was like a 5-digit number or something. And now the students that are there get 7-digit ID numbers. So in order to keep mine, they had to add a few zeros at the beginning of it to keep, to keep it active if I go back and take a continuing ed course or something. Very fascinating. Now, a lot of companies don't necessarily issue them sequentially, but for our example, that's what we're going to do here. So let's get into our code. And we have a bunch of code that we wrote last time. And the last thing that we put into our main method was the command to run the television function that we created. And I'm just going to comment that out. We are going to have to run the code that we create here, but not quite yet. First, we just have to build the class. So since we've been doing all the work basically right inside here, I am going to do a little code collapsing, right? We can always re-expand it if we need. So I'm going to collapse television. We're not going to use pet right now. We will come back to pet though. No cats, no lizards. All right. Let's collapse down the rectangle class and the cube class and just kind of clean up our code a little bit. So I don't know if you guys have been in the habit of using those tools in Visual Studio, but most good IDEs have that. So we get line numbers, and then you get kind of this like margin space in here where you can collapse your code down so you don't have to scroll forever to get to what you need to. That's really kind of the point. If you label things nicely, that helps, right? And I think I showed you guys like the trick. For example, I'm pulling over my example file here, where you can set up regions, right, in the code. And even my primitive Notepad++ tool has that capability. So I can set up a region and an end region, and I can collapse that whole down that way as well, right? So you can create like basically a container out of comments and use it to collapse your code. Just keep that in mind, because when you do get longer code, it is cumbersome, real frankly, to scroll to look for stuff. And then, did I just pass it? It's like that kind of thing, right? So if I'm not going to be using this other stuff, let's just squeeze it all down and we'll work on it like that. I do have a lot of blank space in here. Let's just kind of blow some of that away, tidy it up a little bit. And whatever new class stuff I'm going to create, I'm going to put up here, kind of like newest stuff at the top, basically, is kind of my approach. All right, so we need to build an employee class. And let's start off by just kind of declaring it first. All right, so let's do public class. We're going to call it employee, curly brackets. And we were asked, in fact, let's just reference the slide here. Fields for name and salary, both passed into the constructor. Field for employee ID, not passed into it. Okay, so I'm looking at 3 data properties here, data fields, right? So in my brain, I like to do employee ID first, right? So I'm going to do that. Yes, I'm copy pasting here for brevity. So there's my employee ID, right? Now this is set to get on purpose, only get because this ultimately will become auto-generated. In fact, let's just put in a little comment here and say, this will be auto-generated, right? We won't have control of it. The software will do it for us. Next, we want to put in fields for the employee name and for the salary. Those will both have gets and sets. And for right now, I'm leaving these public. Okay. Generally, why am I leaving these public? So think about this. Is it possible for your salary to change? I would hope so. I mean, you'd like a raise every once in a while or a cost of living increase, correct? Yes, absolutely. And preferably, you want to see that salary go up over time, and that usually does happen. So that's why that has to be public. It has to be allowed to change. Now, what about a name? Should a name be allowed to change? Okay, well, yeah, because real frankly, okay, well, guys don't see this as often, but women certainly change their names when they get married. And there is a trend now that guys are starting to do the same thing. Do you guys know anybody where the the husband is taking on the name of the wife? That happens these days, right? There's no rules for that, and there's no rules that you have to actually change your name when you get married either. But in this case, we're allowing it to be changeable because it's possible that a person's name might change. All right, so it also talks about having a constructor. So let's go ahead and make a constructor function here. So let's do public employee, put in our parens and our curlies. Let's split those curlies apart and then get them into Microsoft approved format. And then inside here, we were told that we should be able to pass in a string. I am doing the question mark thing for name and a double for salary. It's okay if you double my salary, I will accept it. No problems here. All right. So now let's attribute these and set the values. So I'm using uppercase, lowercase to keep them separate. Do the same for salary. And then we got to talk about this employee ID thing in the auto increment. But you know what? That's going to come on the next slide. So let's just read, make sure we got everything. We got an employee class, field name, salary, both passed into a constructor. Field name for employee ID not passed into the constructor. We achieved that. And then each employee that is hired gets a successively higher ID. And now we have to figure out how to do that. Now the math's not hard, right? It's like employee ID plus one, basically, right, is the math. Or employee ID plus plus could accomplish this. So it's a simple increment. So what we're going to do is we are going to add a static field at the top. And notice here I'm using the underscore convention here, calling it next employee ID, and we're going to pre-initialize it to 1. So let's go back to the Visual Studio here and let's add that in up top here. So I'm going to say, no, I got to be careful here. This will be private. We don't want this to be changed by anything from the outside. And it belongs to the class, so it's static. We were told to make it an int, and we were told what to name it. We're going to say next employee. So, and actually next employee ID, I think is what they told us to name it. And we're going to preset it to 1 and put in our semicolon. So that task has been accomplished. I will flip back if you guys haven't typed it in, so don't freak out. Go into panic mode or anything. In the constructor, we want to kind of handle this though, because that's the logical place to kind of increment it. And first thing that we're going to do is we're going to take that new field that we created and we're going to assign it as the employee's ID, and then we're going to increment it at the same time. So we can do it basically with the code that you have here, right? But I'm going to do it like this. And I want you to think about this here. So I could write the code exactly like this, but I'm always about like if making my code a little more efficient. If I put an increment here, will the first employee ID still be 1? You guys remember like we put the plus plus at the beginning and the plus plus at the end and they behave differently? I don't know if you guys recall that or not. But here's kind of the way I'm going to do it. Instead of writing that second line of code, I'm just going to put the plus plus here. This is a post increment, so it increments afterwards. we'll see that in action as we go. But there's the increment and the assignment at the same time in one statement. And I think that's a nice, efficient little way to do it. I mean, we could also write the separate line and just say underscore next employee ID plus equals 1 or plus plus or plus plus in front of it. It doesn't really matter after the fact. But this to me is a more efficient way. All right, let's see what the next instruction is. All right, so now it says create a getter that returns the static field. Now the reason we have to create a getter to return the static field is because the field is private, an outside call to it as a field will never work, right? It's private, right? So we have to write a method to do the access. And then the question becomes, should the method be static or an instance method? So in other words, does it stay with the class or does it travel with the instance? Okay, so here's kind of, okay, so they're saying here in the driver class, write a loop that creates a bunch of employee objects. And I'm not gonna really do this step, by the way. I'm just gonna kind of do that in the aftermath. And then to basically for you to experiment, and then you can discover, can static methods access the instance fields or vice versa? Okay, and there's an answer to that. They cannot access the instance fields or instance methods. So remember, they travel with the class, so we can't directly just like write code to pull it back. It's just not going to work. So if I wrote code that looked like this, right, this would not work, basically. Right. And because we're using the keyword static here, but we're trying to pull employee ID from the instance, it's traveling with the object, that won't work, right? But the general approach of writing static, that is basically correct. Let's go ahead and create this method here. So we're just going to add some lines of code here, and we're going to type it as follows. Public static int, right, because it's an integer, and we're going to call it get next employee ID. Do we need to send anything in? No, we're just returning a value. So there's nothing that we have to pass into it. So it's just a return statement. So we're going to say return underscore next employee ID, whatever it happens to be. Now, keep in mind, we've done an increment, you know, in there during the construction. And once that's built, what this is going to pull back is from the master class, what the next value would be. You guys feel where I'm going with that? And it's pulling it from here. This is static. The method that's pulling it is static, meaning that this also belongs to the class. The data field belongs to the class. The objects that are created from the class don't include these. So when we make the call, static allows it to bypass the instance and go directly to the class to pull the data, keeping in mind that we're tracking the value of the IDs in the class file, which is not accessible otherwise. Pretty cool, actually, right? When you think about that. And this is really actually, I think, a good scenario because we don't want that to be changed accidentally by an instance to a value, and then all of a sudden you have people with the same ID numbers. Not good, right? That's not a good scenario. Now, if we kind of do this, I mean, we got to test it out. And what would be helpful to test it out is that we have a toString method added here so we can kind of see what's inside of it, right? You know, just to print everything out. So let's add a toString method at the bottom too, right? Just for the sake of output. A couple more lines here. So we're going to do a public, right? It's a toString thing. So there's one in the master class of objects. We have to do an override. Remember, this is like last week's stuff or last 2 days ago stuff. So we're going to override it. It's going to output a string. We're going to call it toString to override it. And then, okay, so it's trying to autofill for me, but you know what? That's not at all what I want. But what we are going to want is we're going to do it in the form of string interpolation. And I'm feeling particularly lazy tonight, so I'm just going to copy and paste it for my solution. So here comes the replacement code here. So we're just going to return a string with string interpolation, pulling back the field so that we can see what they are. The salary will be formatted as money, which makes sense, right? Since it's money. Now let's go ahead and create a function that's going to instantiate some employees, right? And I'm sorry if I moved the screen too fast. And it's going to generate some employees, and then we'll output them and see that it's working, right? Hopefully, right? And then we'll call upon the static values. Hopefully the ID numbers increment correctly, and we can return the value as well. All right, so let's head up top here. Not that we have to travel very far right now, but we had created a few different methods here, or excuse me, these are functions. And notice how like we're using the keyword static here, and now hopefully it starts to make a little more sense, right, as to why. So basically that tells us that static is, it belongs to this class file, right? And we're never going to instantiate this. That's what that means, right? It belongs to the class. And we have no intention of instantiating these functions or the main method here, right? We have no intent of that. We don't want copies floating around. These are just meant for this class. In this case, it's an executable, right? But same concept still applies. All right, so I'm going to get to my sample code here. I do want to type some of this out, but I got to think of a good name and what I named it before, and I guess that makes sense. We can call it static demo. I think that's a good name. There's my curly brackets. And then we need to create some employees. I'll type out the first one manually, then I'm going to do some copy pasting just to kind of give you the feel here. So we're going to say employee, and I need to come up with some sort of name here. I'm just going to call him, EM1. Sounds fine to me. We'll say new employee, and then we're expected to send in a name and a salary. You can see it's pulling it right from the class file. So let's put in Mario, and his salary, maybe it's an hourly wage, maybe that's kind of a way to do it. So I'm going to put in 20.15. He's making $20. Let's be kinder. $20.25 per hour because he's so valuable to us. Then let's go ahead and console write line this. And we're just going to basically put the employee inside parens, so we can see the reference in memory, basically. And then this one, once again, I'm going to get a little lazy here because I don't want to type all this. And I'm going to console write line using string interpolation. And notice how I'm doing a call here to the instance, and then calling the get next employee ID, which is a static method that belongs to the class, to pull back the next employee ID from the blueprint class, if you will. Right. Now, before we can run this, of course, up top here in the main method, we do need to make a call to that function. So we're going to run static demo and put in our semicolon. All right, let's go ahead and execute this. So here comes the run, and this will be the first of a few. And so when I do the right line of the object, it says one, Mario, salary 2025. And really we should add per hour, whatever. Doesn't really matter too much. Maybe we should um, you know, put in like ridiculous amounts just to see. But the ID was correctly set to one because that's where it was, right? It incremented after because the plus plus comes after. And then the next available ID is two. Okay. So we can prove now, if you guys are following the exact same code that I'm doing, and I don't know how many of you are actually doing the process of actually following along with me, but in the chat, I'm going to drop in the next 3 employees I'm creating. So if you just want to copy the code, there it is. So I'm pasting them in for my example. So now I have an employee 2, 3, and 4. And you can see I'm pulling in, Mario, Mario names here as my example because I figure most people will know what those are. And we're giving them different salary amounts. And now we've instantiated 4 objects, right? And now if we run the code again, hopefully you'll see that the incrementing is working correctly. So here's the output, not on top of the code, so you can still see the code. And you'll notice the ID numbers, which is the very first part of each line. Then it tells you the next available ID. It shows you that all of it is working correctly. Right, so that's kind of the example. If you guys are trying it at home, are you guys getting it to work? All right. It's not too hard to follow along, right? But this concept is kind of a weird one, but this is a really good, example because you wouldn't want to recreate an ID number. I recently had gone to my credit union and I wanted to open up a new account, and to replace an account I had closed years ago. So, basically the story is, I used to have an account at this bank that I've had since I was a kid. And I used to have checking and savings, but after a while, I never used the checking. So I just, deactivated it and kept the savings account. And then I went back in and I thought, you know what, I have some reasons why I want to reactivate the checking. Can you just like turn it back on and give me a debit card? And the guy's like, we can't do that. I have to give you a new account number. So my old account number was basically put into the pool of like account numbers you can never use again for the checking account. And so my only option was to create a new account number. And I thought that was kind of interesting, but there has to be some similar logic like that in their coding engine. And why? Because we don't want to recreate the same ID number, right? And that's the why. All right, let's move on here. And we do have a try it out on the next slide. So, and so now we're going to use a different scenario here. And for this try it out, what we're going to do is we're going to use the rectangle class again. Now, what I'm going to do is, I know we already have one, but I'm going to create a new one and I'm going to call it rectangle 2. So we can leave the old one alone. But it wants us to add to it a static int named count that starts at 0, and then a method named getCount that returns the value of count. So it should be kind of a repeat of what we just did, if you feel what I'm saying with it. And it says in the rectangle constructor, increment the count. In the main method, create a few rectangle objects and use the getCount method to print how many have been created. Okay, sounds pretty reasonable to me. So let's go ahead and perform these steps. And we'll begin by me collapsing the code on this screen because there's too many lines of code on my other screen now. My Notepad++ has the same problem as my Visual Studio. Let's stop the program from running here. Let's go back to Visual Studio. And we do have the employee class here. I'm going to collapse this one down now. And okay, well, that's right. The rectangle class isn't even in this particular program, is it? No, or it is, right? Because we did, I'm trying to remember here, we did rectangle and cube. So we might borrow a little bit of stuff from here. In fact, why don't we borrow, gosh, I'm trying to think of how much of this we could borrow. Let's just borrow this. You know, I think this is a good place to start. Heck, I'll borrow the whole thing. I'm just going to paste it in. Let's paste it in. I guess I'll paste it in here so it's close to the other one. And then I'm just going to rename it because otherwise it will throw an error. So I'm going to call it rectangle 2. All right. So we have like the basics are already in place. And, you know, one thing that, you know, if you're still curious, we could still use our get area, you know, if you want to. We could still have, and here, you know what? I'll be kind. If you guys are trying to code along, rather than waste your time typing, here's the get area if you don't want to type it. And the next one I'm going to use, which is my toString, both in the chat. And I'm just going to add these in just so we have a little more functionality to the class. So you guys have those in the chat. Now we were asked to add up top here in the fields, to add a static int that's private. So we're going to say private static int, and we were asked to call it count and preset it to 0. Okay. That's going to be its initial value when it's first called. Until it's called, it will never be created, by the way. All right. The other thing that they asked us to do is increment that counter here. And interestingly, since we're not passing it in, right? And I'm not going to assign it to an instance field, it's just going to stay with the class in this case. So I'm just going to do, yeah, count plus plus is all I'm going to do. It's going to increment it automatically. If you want, and see, why is this underlining red? Because I renamed my class and I didn't rename my constructor, by the way. So let's do that. But you know, what about the scenario? If you remember back to our rectangle class, what about the scenario where we were, you know, we have basically overloaded constructors. We could have a constructor that accepts 2 values, or we could have a default constructor that pre-assigns some of this stuff. Like we could just set length and width to 1 and increment the counter. So either way, we can do it either way, right? So if you don't know what the sizes are, you can create it and add the sizes later, but it still increments the counter. All right, so there's all that capability there, folks. Now what we need to do is we need to go ahead and create some of these. All right, so I'm going to come up top again, and I hope I'm not moving too far out of the way on the screen here. Let's collapse down the static demo function here. We're going to create a new one. So we'll create a static void. Oh gosh, what should we call this? Rectangle demo? Or what are we demonstrating here? We're still demonstrating the static thing. So let's just call it rectangle demo. That's good enough. Doesn't really matter what it's called, honestly. Just to we want to get the code to run. And of course, let's follow the same procedure here so we don't forget. Let's comment out static demo, and let's drop in rectangle demo, parens, and a semicolon. So now we'll run. All right, same kind of scenario here. We need to create some of these objects. So we are going to call rectangle 2. I'm not very inventive today, so I'm just going to call it R1. And we'll say new rectangle. And let's do the first one without the constructor, without the parameters thrown in. And then let's do a console write line. And inside there, let's just return the count. And so the way we're going to do that is we're going to get, oh wait, we can't. Did we create that yet? I don't think we did create that, did we? So let's go down here. Yeah, so we have 2 constructors, a get area and a toString, but we don't have the count yet. So we do have to create the count. So let's put that right underneath the constructor, the second constructor here. And this will need to be public. It will return an integer, right? Because that count is an integer. We'll call it get count. And the question becomes, do I make it static or do I not? So what do you guys think? Should I make it static or not? This is the question. This is what I'm trying to lead you to here. I want you to see the kind of the fundamental difference here between how we're declaring this as a private static that has a value, and when we're going to be pulling back this value, right? Well, oh yeah, well, of course it's not returning a value because I haven't typed it in. But if I'm going to return this, what would I ultimately return? I would return that. Are you noticing this is not underlining red? So the question becomes, does count actually travel with the instance? Okay, so the answer is basically it cannot because it's static. So does get count have to also be static? No, the answer is obviously if it did have to be, this would be underlining red and saying all sorts of nasty stuff to me, calling me an idiot and whatnot. But obviously it doesn't need to, because the method will travel with the instance, and the instance can access the static field. See the difference, right? So the method belongs to the instance, but the data field belongs to the class. So we're kind of looking at both approaches now. So you can write a public method that travels with the instance that can still access, if you will, the class that created it and pull back something that we could not otherwise pull back. So that's kind of the grand takeaway here. So now if you look at this code to output it, now we can call get count because we have it. Let's see right there on the list. That will reach into the instance method, travels with the instance, and output it to the screen. And you know what? Can we just try it like this, just to make sure it's working, just to prove that it's working? Here comes the run. And there it is. Yes, we have 1 rectangle. You are correct, program. Thank you. That's all we asked it to do, correct? We're just looking to get that value. All right. So if we create 1 rectangle, let's create another. Here it is in the chat. That's our save your typing here. So here's my second one. This one I'm feeding in 2 double values. Okay, let's run it again. Do we now have 2? We do. So it counted the first one, it counted the second one. So whether or not I'm using the default constructor or the one where I'm sending it in, it's still keeping count. Both of them have their own get count method attached to the object. So R2 has its own get count, R1 has its own get count. Both of them have access to the static private field and can return its value and change it, but it can only be done from the instance, right? So you see kind of the difference there. Now, let's go back to the instructions here. And it says in the main method, create a few rectangle objects, use get count method to print how many have been created. All right, you know what? Not that I'm not trusting that it's doing it right, but can we create some more rectangles, right? And I could just kind of use the same approach. I could do rectangle 1, rectangle 2, yada, yada, yada. Or, and I'm just going to kind of put it out there, or we could type code like this. This is all coming in the chat. Just want to save you guys the time of typing it. Now you're going like, why didn't you do this at the beginning of class? You should have shared the, the code with us before. Well, you know what? I'm building a character here is what I'm doing. Typing is its own reward. All right, so I'm going to create a list of rectangles of rectangle 2s, right? It's a list filled with rectangle 2s. And I'm just going to call it rectangles. We create the new list. And then I set up a loop. The loop goes through, and then using I as a counter there, we run it a bunch of times, and we add a new rectangle with the default constructor. Then we will run it, get the count from the first rectangle. So here's the example. So like, why are you doing this? You already did this one, and we proved it works. Well, the count has changed since we've done this. So if I run the first instance of this again, will it correctly pick up the new value? This is what I'm trying to prove, right? And then, of course, I can also, find the rectangle in position 0, or frankly, any of the positions that we created in the list, and do a get count, and that should match, right? And I could change that number. It could be 0, it could be 3, it could be 5, right? How many are we creating? Well, 0 through 9 is what we're creating according to this, right? So 10 values, but 0 through 9. So any number I would put in here, in fact, we could, if you want, you could prove that by, typing in like one number between 0 and 9 in here. I'm just going to type in 3. Let's try this, right? And see if it truly works. Here's the run. All right. So the first two, yeah, we knew those worked. But now it's like the count is 12, the count is 12, the count is 12. All three of them, all different instances. One is a standalone instance. These are inside a list of rectangle 2s, but they're all pulling back the same count from the class from which they were created. So the data field belongs to the class. We can change that every time we create an object. And then in the aftermath, I can call upon any one of those things that were instantiated and basically prove that they're all still pulling the same value. They're not like keeping track of the values separately. All right. A lot to absorb. So, a lot to think about there. Really good time for a break. Let's do like a 7-8 minute break, so you guys can do a little brain decompress and think about that. I'm also going to take a quick little break here. So I'll see you guys in like 8:09 or 8:10. We'll come back. All right, we're going to move on now to our next topic, and the next topic is aggregation. All right, so let's take a look at how this operates. There's just a few slides on this before we do our next try it out. And it says when you think of the word, aggregation, it basically means a whole made of parts. So when we aggregate things, we're taking a bunch of separate things and putting them together as one. As simple as that. So when we take one object that contains another object, that's what we're talking about here. So we can create objects that contain other objects. Case example, when we created a recipe that contained ingredients, the recipe was an object, the ingredients were an object, right? And the point that's made on the slide here is it mimics real life. So for example, a house, which is an object, contains doors and windows, which are also objects, right? They all have properties. They all have capabilities. Doors open and close. There's certain height, length, and width. Windows open and close, but a different way usually. or different shapes, right? And there's an example. The window behind me here is a really weird one. It's got an oval top to it, and so that has a special type of property in itself. Now, there's before we were using the is verbiage, and now we're changing it to a has a verbiage, right? So it has a relationship. So aggregation creates what we call a has a relationship. So for example, a course has an instructor and a course has a textbook, right? So you can think of the instructor as an object, the textbook as an object, and the course as an object that potentially contains both of them, right? So one complicated structure can hold other complicated structures. It's really not that hard to conceptualize if you think about it, right? And all you have to do is draw from the real world, right? And you can apply this to just about anything. All right, so why don't we try this little try it out? And our goal here is it says create a company class that contains 2 employees. So we're going to make a new class, and that class will have 2 employee objects, or the ability to create employee objects within it. That's a better way to see it. And they are telling us that we want to have 2 employees, a president and a vice president. The company should also have a string for the company name and an int for the year it was founded. All right, so let's get to building it. We're going to start with our class file. We're going to do a little bit of code arranging here first. So let's start up at the top of the file, and let's comment out our rectangle demo since we're done with that one, and collapse the code down. We have our employee class right here, and I'm going to go ahead and create the company class right next to it. So let's do that. Let's create public class, and we're calling it company. Curly brackets. So we need 2 employees, vice president and president, the name of the company and the year founded. All right, so here's how I'm doing that. First, remember, I'm tempted here to just continue my copy pasting. So here's the kind of 2 generic data fields. Here you go, folks, in the chat. So we have a string for name and a year founded. I mean, I guess I could be nice and put in the question mark and get rid of the green underline, right? I will be real frank, that is not my habit for C# coding, but it seems like this new version of Visual Studio is really pushing it a lot. So I was like, okay, fine, I'll do it. I'm just trying to get into that habit. Old coding habits die hard for sure, right? But now they also want us to add here 2 employees, and and kind of the one kind of approach here, or really what they're trying to do here, is they're trying to give the example that we can have lots of different companies, and most big companies will usually have a president and a vice president, and probably a CEO, and et cetera, right? A lot of companies have multiple vice presidents, especially when they get really big. Hey, I'm the VP of operations. I'm the VP of accounting, et cetera, right? But we're just setting up president and vice president. But instead of creating a string variable, right, that would hold the name of something, we're creating it as an object that's named based upon the employee class that already exists. So just to review, all employees have an employee ID, a name, and a salary, and their next, ID number, whatever that's available. And then they have all these capabilities. We can construct them. We can return the employee ID for the next ID, and we have the toString method. And so all the employees will have that capability. I don't have to rewrite that code. But instead of using a traditional variable here, I am instead going to use an employee object, right? and I'm creating one here, basically is what I'm doing. The first one is going to be the president, right? And the president is going to have a get and a set. Why? Because we might fire him. you know, and you know what? That happens. Right? And I got rid of my closing curly bracket there, so I was being sure to put it back. Now, conversely, we can do the same thing with vice president. So if you want, you could just copy that code. This isn't very hard to type, folks, so you may as well just type it. All right, so vice president with a get and a set, also an employee object. So when I create a company object, it will have name, the year founded, and then it will include a president and a vice president, which are its own complicated object embedded inside of it, right? Just like a house has doors and windows, for example, which are also complicated objects, right? Does it tell us to do much else here? All right, well, I guess we should prove that it works would probably be a smart thing. So why don't we throw in a constructor function so we can build it. I am pasting the code just straight in the chat because I really don't want to type all this out. You can tell I'm in lazy end of semester mode here, right? All right, so here's the constructor. We're expecting it, and take a look at the syntax here. We're expecting it to receive the name and the year founded, but also the things that we'll use to create the objects in the employee object. So we're going to feed in the president's name, the president's salary, the VP's name, and the VP's salary. And then in the constructor, okay, name and year are just kind of like what we're used to doing, right? We're just taking what's fed in, we're setting it to the instance variable. But president and vice president, because this variable here is expecting an object of type employee, right? That's its data type. Then we can instantiate the new employee using the values that were fed in right in the constructor function. So we will call the company constructor, and then that will, provided we throw the right stuff in, will also construct two employee objects also. Pretty slick, right? Yeah, that's pretty slick. All right. That's all of the class code. So you can see that here, and I'm assuming you guys all have it since I copy pasted it for you, right? Now we need to write the code to run it. So let's come up above and let's create a new function here, following the same pattern. So we'll do static, void, and I don't know. How about company demo? Sounds good to me. Curly brackets. And you know what? Let's not forget to run it. And so I'm going to be extra lazy here and just copy that and paste it in and just add in a semicolon so it's ready to run. Now we need to type some code. So here, let's create a company. In the chat. And that is kind of a long line, so that's why it's scrolling over. But if I could move that over, it would normally fit. Does it really matter if it's on another line? I mean, do I have to have it up here? No, it doesn't matter. So that's kind of the nice thing about a C-style language that has the semicolon, because when you're working in a language like Python, where you can only do one statement per line, you have to use special continuation characters to move your code to the next line. But here we can split it between two lines. Still works just fine. So basically what it's telling you is this space here that I'm highlighting is ignored. Still works. So notice the call on this though, right? So what are we building? We're building a company object, right? Based on the company class We're naming it company, lowercase, whatever. And then we're saying new company, what's its name, toy factory, what was the year founded, okay, who's the vice president, right? This is like seasonal, obviously here, right? I figured, but you know, 'tis the season, and if you're Jewish and you're celebrating Hanukkah, I don't know if you have that equivalent or not. I don't think so, right? But Santa Claus, Santa Claus gets paid very well, you know. He only works 1 day a year, so he should get paid really well. You know, he probably delivers all the toys in a couple of hours, so he's doing pretty good for himself. And then Mrs. Claus is the vice president, and of course, she insisted on having the same salary, so that's kind of the rationale. The next thing that we want to do is we want to see if, you know, did the information actually travel and get created. And I'm just going to have two write lines here. So let me grab those. Okay, in the chat. And then I'm dropping them in. So we're just going to write line the company president, yes, the object, and the vice president as an object. And we already saw how employees print out, right? It's going to show their employee ID number, right? And you know, anything else. So what will the president's ID number be here? Right. Now, if you guys are thinking where it's like, well, you did an array and you did two other things and it was at 12, and now we're building two more, the president's going to be 13. And Victor, you're trying to like sign it to me, right? Yeah. If you're guessing 13, okay, well, that would be maybe a logical guess. So Santa might be 13 and Mrs. Claus would be 14. But here's the difference. I stopped the program from running, so it still wasn't loaded in memory. So those don't count anymore. This is a new instance of the program running. That old memory was wiped out. So Santa should be 1 and Mrs. Claus should be 2. All right, let's check it out. Let's see if it works. Let's try it out. There you go. Now, interestingly, and just to prove, right, like with those static methods and the different objects, if I was to re-enable the static demo, that's the one that did the employees, that would run first. The count would go up to 12, and then Santa and Mrs. Claus should now be 13 and 14, right? In an ideal world. Let's see if that's true. Didn't quite work that way. Why? Well, let's take a look at the thing that drove the static demo here, right? Well, we only created 4 employees. The 13 and 14, that was related to the rectangles, not to this. So we got all the Mario Brothers characters, you know, and we have Santa and Mrs. Claus. You know, it's kind of fun to have fun with code, especially since we're learning. We should kind of be silly about it. But yeah, there is a total of 6 employees. I don't know if these guys work for Santa and Mrs. Claus, but maybe they do. They sure get delivered a lot on Christmas, that's for sure. Right. All right. So that was the try it out there. But the point of it, once again, was that we can create a company object that contains other objects as their data fields, right? And it has a relationship, once again. Make sure that console is done. All right, let's carry on, folks. I'm hoping everybody got it to work. All right. Nod and smile. All right, thank you. All right, let's move on to the next topic here. And our next topic is talking about these two things. And you know, the concepts are interrelated, which is why they're kind of grouped together. But we have this like really weird word, abstract, and we use it a lot in programming, by the way. So when we create things that represent other things virtually, because we do this electronically all the time. We use this terminology where we say that something is an abstraction of something that's real, right? So let's take a look at the slides here, and hopefully this will make a little more sense as we read through. So the difference between something being abstract and it being concrete is pretty simple. It says you can't walk into a pet shop and buy a pet. Yes, I'd like a pet, please. What's the question that follows, right? Well, what kind of pet do you want to buy, right? You can't just come out with this generic thing that's a pet. It's going to be a specific type. It's going to be a dog, a cat, a fish, a bird, whatever, a lizard, going on that. But you can't generically buy basically the archetype of a pet. You can't do that. It's an abstract concept, right? And it's not a concrete thing. It's just the thing that we use as a word. A dog is a pet, but a pet is not a concrete thing until you have a dog, right? Then you can call your dog a pet. You see what I mean? So it's an idea, not the actual thing. So read through this here. It says, if we don't have generic pets in the real world, maybe we really shouldn't have that in our programs either, right? And this is where kind of the concept comes from. So somebody sat, probably 20, 30 years ago when they were building this type of code and said, you know what? If we're doing these abstractions, does it make sense to follow through on that if it doesn't actually need to become an object? So for example, I would never instantiate a pet object on its own because it can't do anything. It's not a thing until it becomes a dog or a cat, right? So probably we shouldn't do that in our programs, is the point. So we have the capability then where we can take classes and designate them as abstract. And it says here, it's still useful to have a pet class though, even if we make it abstract. It captures everything that generally is true about all pets, right? And if you remember, like kind of what we did here, we had assigned an age and a name, and then we came up with this like generic speak, method, as if every pet can say the word hello, which is not true at all, right? All right, so that being the case, how do we make it abstract? We just simply add the keyword in the mix. So we just say public abstract class pet. Now it basically can only exist as the superclass to other pets. So we can still, basically draw its capabilities into creating a dog and a cat and a bird, but we can't run the code at the bottom anymore. That's the point. So I couldn't say new pet and create one with the constructor. It just won't do it. It will fail, right? However, a dog can still be instantiated as a subclass of the superclass pet because it is abstract. We're pulling its capabilities in, but now it's a dog. All right. So, so it says, what do generic pets say? Well, and rightly so, the speak method is kind of silly because no pets can really say hello except for, a parrot, right? Perhaps, because you can actually teach them to speak English. And do pets really say hello? I guess not. Or did we just not have a good default? Okay, perhaps we didn't have a good default. So, maybe this really shouldn't be part of it, right? Maybe this shouldn't belong to the superclass. Maybe it should belong to the instance, So we can make speak also an abstract method. Now, this is really interesting. So if we don't want to predetermine what the default for a pet can say, we can declare a method as abstract, meaning when I create an object as a subclass of this class, it will build a method called speak, but the class has to designate what it's going to say. That makes more sense than what we did before, if you think about it, right? So, in other words, we'll create a dog. It will have an age and a name. It will have a method that travels with it called speak, but we will tell speak in the individual instance what it's speaking, whether it's woof or arf or bow wow or whatever you use for the, whatever the sound you think a dog makes. Certainly not hello. Right? So we can create an abstract class, and we can create an abstract method that then gets propagated to all the instances. All right, so it says abstract methods don't have a body, just a header. So we don't put in curly brackets and we don't write any code inside of them. We just declare it, public abstract void speak, right? The class, or excuse me, the instance will take over then. Subclasses will override it with their own information, but it will exist, right? Okay, enter in this concept now of polymorphism, right? So this is one of these fancy computer speak words, right? Intended to, make people go like, what the hell are you talking about? What's polymorphism, right? And the word itself, as is indicated here in quotes, it literally means many forms, or many ways of being, so to speak. So a superclass variable basically can contain any of its subclasses. So for example, this pet equals new pet thing. Okay, not so much, by the way, but pet dog equals new dog. Dog is a pet. So here comes that is a concept again. So this allows us now to basically use the superclass, instantiate the dog, and then it becomes a pet dog, as opposed to like how we were doing it before. So this is really actually more appropriate. So in other words, a pet can have many forms. I could also have a pet cat or a pet turtle or a pet lizard, hopefully not a pet human. That would probably not be cool. But some people try to do that too, right? So, pet goldfish, maybe. All right. Now, the interesting aspect of this is that the inheritance of this won't work in reverse. This is a one-way relationship. So the dog is a pet, but the pet is not a dog, right? So when I say pet generically, dog is not implied, but the dog is certainly a pet. And so notice this, it says you can't assign a superclass object into a subclass variable. Kind of an interesting thought. So you can't take the pet object, that's way up here, if you think of it like that, and put it into a subclass variable. So that won't work. I can't do it in this order. I can't say dog Spot is a new pet. No, not going to happen. Other way around is okay, but this way it's not. And I don't remember if I have an example on this. I don't really think I do. So yeah. Or do I? I guess I do. All right, so, okay, I have a little example on this. Let's go ahead and mess with it a little bit. So let's do a little code collapsing. I'm going to collapse down my employee and my company stuff, and we already have a pet class here, so it probably makes sense to maybe replicate this a little bit. I'm going to expand that for right now. Like I did before with rectangles, I made a rectangle 2. I'm going to do a pet 2. I want to leave this example alone and create a pet 2. So why don't we just take all of this code. Let's paste it down here. And now I'm going to call it pet 2. Like that. We don't have a constructor here because we don't need it, right? And do we still need a string, name, and an int age? We do, so those will stay in place. But here, let's try doing something kind of weird here. Let's go ahead and try to do a constructor. So let's do public pet2 construct curly brackets, and let's feed in this stuff here. So we're feeding in name, we don't know. We're not feeding anything in, right? So no, the name is unknown and the age is 0. Okay. Now, this would be in the scenario where if I create like a generic, think about this, if I create like a generic dog, but I don't feed in the information that like his name is Spot, right? Sometimes you want to think about a pet's name before you know, oh, I love you so much, I'm going to just name you George or whatever, right? That's not how it works, right? Sometimes you wait and see what the personality is like before you name them, so it's appropriate. All right. Now, we are going to add some abstract methods here. So we still have speak written out like the old-fashioned way, but we're going to remove this. Well, we're going to remove that part of it, right? Because we already learned we don't need the curly brackets in any code. And here, we're going to actually change it from a virtual, right, to an abstract. So we're going to say public abstract string speak. We're not writing any code for it. And then notice it says abstract methods, which I have as a little comment here, must be defined in the subclasses, just as a reminder, right? The reason this is highlighting, right? It's abstract, but it is contained in a non-abstract pet type. Oh, yeah, that's right. So in order for this to work, the pet also has to be abstract. I didn't do that, right? So we don't want to, allow it to fail here. So we have to also call our pet class abstract. Notice the underline go away. So pet2 is abstract, meaning I cannot directly instantiate it. Its speak method, which will be defined in each instance, is declared here as abstract, but the instances must actually do the coding for it. We still have the override here. That's helpful to look at the contents once we create them. So we'll just leave that alone. Tidy it up here a little bit. Just remove that extra line. You guys good? Okay. All right. So now that we have this created, so I'm going to kind of go back to like this concept. All right. Well, if we want to demonstrate this, here's kind of the second aspect of it. So if I can't instantiate this directly to see if it works, I mean, the whole point is we're going to have a subclass that's going to pull from this, pull in its features, including the abstract class, and then we'll override that speak method with our own, but we need to instantiate pet objects, right, in order to prove this. So we have to create some more classes to do that. So let's come down here, and I'm going to create some pets. Well, I'm going to create a public class. How about this? Let's have a cow as a pet. Some people do. I'm just saying, and I'm not judging. They're fuzzy mammals also. And notice cow is inheriting from pet2. Right. Now, what unique features do cows have? Well, they have lots of unique features, but I don't want to sit here and type like udders and whatever. And actually, a cow implies a female, animal, right? Because the male animal is called bull, right? Okay, but we're looking at that. What do cows often have? And you know what? Well, it depends. Cows can sometimes have spots. So I'm going to create a Boolean data field called has spots. And this can be get and set. So some cows are brown, right? Now brown cow. And some cows are black and white and have spots, right? Can be either way, but they're still cows, right? So that could be a data field, just for example. You could think of a bunch of others, color, whatever, not important. Let's just get the example moving. When we do instantiate the cow, I mean, here's my constructor in the chat. I'm going to construct that cow and we're going to pass in the Boolean value. Is this a spotted cow or not? Okay. And we'll assign it to the instance variable. Then it comes time now that we have to actually worry about that instance method because it's declared in the superclass, I have to have an override for it here. And you'll notice why on earth, okay, well, first of all, we don't need this here, do we? Right. But why on earth is this underlining? It says cow does not implement the inherited abstract member of pet.2 called speak. So it's telling us, the red underline is saying, hey, you're pulling in an abstract method here and you haven't declared your own version. You must create your own version, right? And so here is my override method of the abstract class, once again, in the chat. So public override string speak. Notice instead of saying, we don't say abstract here because we're overriding the one in the superclass. That still applies, but we're naming it the same thing. It's returning the same type of data, and now it returns moo, right? Because that's what a cow says, is moo. Also helpful, just to make sure that we're able to see what's going on. Here is also a toString method, right? And remember, we did have a toString method in the superclass that's overriding the object class. Remember all that stuff? And then we're going to write a local override toString, which overrides the other override, right? You guys feeling where I'm going with that? It's still called toString. And this one is going to pull from the base toString, and then it's going to output this, what do we call this? A ternary statement, right? Where what it's basically asking, this is a Boolean. Does it have spots, true or false? If true, it'll say has spots. If false, it will say does not have spots. Right? And it's right in the return statement. And it's kind of interesting, right? So when we do this toString thing, and we can kind of concatenate on the fly here if you guys are wondering what's going on, right? We're concatenating this on the fly. It's not inside parentheses and stuff. This is how C# operates, right? So base toString takes all the information, turns it into a string. The plus sign concatenates a carriage return, new line, and then it concatenates the output of that if statement. It's a ternary if statement. So it'll either say, whatever the cow is, has spots or does not have spots. All right. So now we need to demonstrate this if you guys are ready. Right. Did I give you the override in the chat? I don't think I did I? I gave you the moo override, but I didn't give you the toString override. If you don't want to type it, there it is. Right. Some of you probably already typed it. That's okay. All right, so now we want to go ahead and we want to write this as executable code. So we can leave those alone. We're going to scroll back up to the top here. Yes, we need to create another method. Let's collapse the company demo. Let's comment out the static and the company demos. And let's write another static function here. And let's call it pet2 demo. I think that's pretty reasonable, right? And let's not forget to call it up here. So, pet2 demo, parens, and a semicolon. All right, well, now let's write a little bit of code. All right, so first thing I'm going to do as a matter of demonstration here, I'm just going to throw this comment in because, I put it in, so I don't forget to say it, basically. And it says, once a class is abstract, you cannot instantiate objects of it. Let's prove that to be true. All right, so I'm just going to drop in this code. And notice what it does right away. And let's read the error message because I always think that's kind of telling. It says, cannot create an instance of the abstract type or interface, apparently that's the thing too, called pet2. Okay, can't do it. Why? It's not allowed. Simple. I mean, that's basically the answer, right? So we can't do that. So I'm going to leave this in place and comment it out. And then I'm also going to kind of add here. So like, if you were thinking that you could do that, you were probably also thinking that you might be able to do these statements too, that I could output that pet and make it speak. But since I can't even create it, there's no way that's going to happen, right? Makes sense? Right, okay. Hopefully it does. You guys can nod and smile, but maybe it doesn't make sense. I really don't know. All right. So let's go ahead now, however, and make a cow. So for example, if I create a cow, right, that inherits from pet2, and we just call it, cow, whatever. I'm not going to make a whole bunch of these, by the way. And this new cow is expecting a Boolean, right, called has spots. And all right, let's think about this here. Does the cow have spots or not? True. Let's put in true. So the cow has spots. That's true. So we're sending that into the constructor. And if I right line the cow object and then also ask the cow to speak, we'll see if everything actually works, right? So I'm going to go ahead and run this. So we're running it. Comes the run. But we have a little bit of a problem. Okay, I don't know if you guys are catching it. Because what it's supposed to do is like the name of the cow, the age of the cow. It did speak though, it says moo. Right? So all of the capabilities of that cow did come through. And then the cow has spots. So apparently that all works. So this came from the toString. This all came from the toString function. We do have a problem with it because the name and the age aren't being sent forward. And then ultimately, when we just make it speak, it does speak. Okay. So the first one is kind of like a dump of everything the object contains. That's the first right line. The second one is just the output of speak. But the reason I'm doing that is to show you another concept here. So let's stop the run on that. And just remember that, okay, so we're not looking at pet at this point. We are looking at pet2. And where did the unknown and the age come from? From the default constructor, right? Kind of an interesting thought here. So those things were set and they're part of the object. So maybe we need an overloaded constructor here. And I'm going to drop that in the chat for you so you don't have to type it. So here's an overloaded constructor. I'm going to take that same constructor and add it here. So we have a, excuse me, a default constructor. So if we don't send in the name and the age, we can only set the spots basically, true or false. But if we have an overloaded one, now I can take the name and the age, and then what happens to the spots? Well, we're not declaring them here. It's not part of this, right? That's part of cow. Name and age are part of the pet, though. All pets have name and age. See the difference, right? So now that we have this overloaded constructor, I can come back up here, and when I create the cow, and in truth, maybe the better way to do this is instead of just changing the first one, let's make it cow 2, right? And make sure you change all the references to it. But in the constructor here, now it's not squawking, right, about the has spots thing, but it also will want, now I want you to think about this. If I'm going to be able to set spots, how am I going to set the name from here if I can't instantiate the other object directly? Here's the scenario. So I'm going to go back down to the cow class, and I'm going to add an overloaded constructor there as well. Once again, in the chat. And that overload, so I have the one that just takes the Boolean, but now I'm going to add another one that's going to take the name and the age. That's going to go to the superclass. See the base command here? So name and age go to the superclass. The Boolean goes to the cow class. And now when I construct it, I have a choice. I can either just send in spots, true or false, or I can send in name, age, and spots. All right. So reinforcing all the skills here once again is really what we're doing, folks. Let's go back up to where it runs. And now in the constructor here, we do want to add a name, and you can call the cow whatever you want. Somebody give me a cool name.
Betsy?
Betsy, thank you. That's kind of like, it's funny, John, it's the name I was thinking also, right? And what was the name? Was Betsy the cow that they used for Borden? Was that where you're getting? That's why it sticks in my head, right? So you guys probably never even heard of Borden dairy products. Well, actually, they're making a comeback. You can buy Borden cheese now, I think. But they used to be the #1 milk producer in Wisconsin, and in fact, in the really old days, so this totally dates me. We used to get milk deliveries at the house from Borden in glass bottles. How about that? Back when there were milkmen. All right. We also need an age as an integer. How old is Betsy? Let's just 3 is good. And has spots is true. Right. Actually, let's make this one false. She's a brown Guernsey or something like that. Right. Let's run this and see if it works. So here's the try it out. Right. So the first one, still unknown name, age is 0, says moo, has spots, and moo. Okay. Betsy, age 3, says moo, does not have spots, and she's mooing. Right. If I did, by the way, so this cow doesn't have a name or an age. That doesn't make any sense. I could, in the aftermath, I could take, so cow dot name. We're not going to call it test. Maybe we'll call it Sally. Remembering all cows are female. And the cow can have an age, and it's not going to be 30. I don't think cows live that. I'm not sure how long cows live. That's kind of a weird thought, right? Let's say she's 5. That's probably a ripe old age for a cow. Off to the hamburger factory after that. So now let's run it again. So it starts out unknown with the age 0, right? Oh, but we're not ever outputting it again. So we're going to have to, after this, we're going to have to right line it again. And actually, why don't we do it like this? Let's just use the same right line. We'll just put it after, like that. Now let's run it. And there you go. Sally, age 5, says moo, has spots, moo. Right? Betsy, age 5, says moo, does not have spots, moo. But it demonstrates all the concepts here, kind of pulling them all together. It also shows that if you use the default constructor and don't set the name and the age up front, you can set them in the aftermath because those are part of the instance. Those are public and they can be changed. They have getters and setters and they can be changed. You guys all get it to work? You're all good? All right. Folks, I think we're at another logical stopping point here. So we have one last section of lecturing to go. And yeah, I could plow through these slides and finish them tonight, but I'm going to be a lot more comfortable if we push this off to Tuesday. And then on Tuesday, we will also work on the lab and the assignment during class time. What I want to do after our break here today is I want to talk about the final project and get us started on that because, like I said, we're a week out, so we got to get a head start here on writing that code. So let's do, it's 9:12 right now. Let's come back at like 9:18 or 9:19, somewhere around there. And I am taking a pause and I will see you guys in a few minutes.